this is the beginning of the Unit 9, and in Unit 9 you're going to learn how to graph parabolas, hyperbolas, ellipses, and circles. Before we get started, we're going to refresh some skills that we learned about last year, and that is applying the midpoint and distance formulas, as well as identifying equations of tangent lines. Before we get started, though, I would like you to please go ahead and factor the following expressions. The first one is 125x cubed plus 27y cubed, and the second one is x cubed minus 3x squared minus x plus 3. Please pause the video and factor each of these on your own, and when you have an answer, please go ahead and restart the video and we will see how well you did. Okay, the first thing that we want to do is we want to recognize the fact that we have ourselves a sum of cubes, which means that we're going to be using the strategy of SOPs. So I'm going to break this apart into a binomial times a trinomial, where I take the cube root of each term, and I end up with 5x plus 3y. And then I'm going to use my first term to use square opposite product square. I'm going to take my first number, 5x, and square it to make that 25x squared. The opposite is going to be a minus. Product, 5 times 3 is 15, so that's 15xy, and then squared, 3 squared is 9, so that's going to be 9y squared. For the next problem, we have ourselves 4 terms, and whenever you see 4 terms, we automatically break it apart into 2 parentheses. So I'm going to put parentheses around the first 2 terms, change my minus sign to a plus negative, and then I'm going to put parentheses around the last 2 terms and factor out the greatest common factor from each parenthesis. X cubed and 3x squared have in common an x squared, with my leftovers being an x minus 3. Plus negative x plus 3, they don't have anything in common other than a negative 1, and you know that you factored it correctly if you ended up with your 2 parentheses being the same. So now I'm going to write a product of my outsiders, which is x squared minus 1, and my insiders, which is x minus 3. X squared minus 1 is a dot, a difference of 2 squares, so I'm going to write that as x plus 1 times x minus 1, and then we have x minus 3. Factoring is not going away, and it will certainly be on your next test. Now, our learning targets for today is for you to be able to say, I can use the distance formula to classify triangles. And then I want you to be able to say, I can write an equation of a perpendicular bisector and write an equation of a line that is tangent to a circle. So those are our I can statements. So the first part of the I can statements is for you to be able to use the distance formula in order to classify triangles. That means that you're giving a triangle a name, and there are 3 different names that we give triangles based on their side lengths. The first one is scalene, and scalene means that no sides of the triangles have the same length. So no sides have the same length. So we call scalene. Next is isosceles. That means that at least 2 sides have the same length. And finally, we have equilateral, which means that all sides are the same length. So now what we're going to do is we're going to be refreshing our memories on a few different ideas that comes with working with triangles and working with different points. And the first one is the midpoint formula. Now the midpoint formula represents a middle point of a segment. So what is the midpoint formula between 2 points? We're going to call those points P being x1, y1, and Q being x2, y2. So that middle point is like going to represent your average. And the way that I remember this is it's the average of your x values and the average of your y values. Now midpoint is just that. It's going to be a point in ordered pair. So think about what average means. Average means take the number that you have and divide it by the total number of things that you have. So in this case, we have 2 x's. So I'm going to add x1 and x2 together, and then I'm going to average it by cutting it in half. Then I'm going to take y1 and y2 and add them together, and then I'm going to cut them in half because that represents my average x and my average y. So it says with your partner, but we don't have a partner. What we're going to do is we're going to derive the distance formula from our picture down here. And what derive means is that we use old formulas to help us to come up with new formulas. So if we were to look at this picture, we know, or what we can see here, is that we have ourselves a right triangle. And the distance from end to end of this side that we have down here that's horizontal is x2 minus x1. It's the difference between our x values. And the distance between, or the length of this side is going to represent the distance or the difference between y2 and y1. And then what we have here is our hypotenuse, and we're calling that hypotenuse a d, a distance between these 2 points. We're going to call that d. So we know from working with right triangles that we can work with the Pythagorean theorem, which is a squared plus b squared equals c squared. So a and b in this case are going to represent our side lengths. So I have one side length that is going to be x2 minus x1, and I'm going to square it by plugging it into the Pythagorean theorem. Then I'm going to write plus, and I'm going to take my distance between my y values, which is y2 minus y1, and I'm going to square that value. And that's going to be equal to my distance between these 2 points squared. So now, if I wanted to identify what my distance is, and I need to get rid of the square. And the way to get rid of a square is to take the square root of both sides. So therefore, the square root of x2 minus x1 squared plus y2 minus y1 squared, that is going to be equal to the distance between 2 points. And that's what we call the distance formula. This is a formula that you should be very familiar with, that you should have worked with a lot last year. That distance formula, once again, is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Please, please, please be careful with your signs when it comes to this formula. So now the question is, how would you show a triangle to be scalene, isosceles, or equilateral? Well, what we're going to do is we're going to find and compare the side lengths of our triangle. And we're going to find those side lengths by using the distance formula. So once you've used the distance formula and you've identified your side lengths, you should be able to state what type of triangle you have. So the first thing that we're going to do is we're going to identify a midpoint. And we're going to identify the distance between 2 given ordered pairs. So the first thing I want to do is identify my midpoint. So I'm going to write m is equal to, and my midpoint represents, once again, the average of my x values, and I'm going to take -5 and add it to -3, and I'm going to cut it in half. So that's my average of my x values. Then I'm going to take my y values, and I have 1 plus 2, and I'm going to cut that in half as well. So that's going to represent the average of my y values. -5 plus -3 is -8, and half of -8 is -4. 1 plus 2 is 3, so we can write this as 3 halves, or you can write it as 1.5. So that's the midpoint. The next thing we want to do is we want to identify our distance. So the distance between these points means that I'm going to be working with the distance formula. And I'm going to write x2, which is -3, minus x1, which is -5. Please be careful with your signs. Plus, we have 2 minus 1, and that's going to be squared. So now I have d is equal to, negative makes a plus, and we have -3 plus 5, which is 2, 2 squared, which is 4. So this is the square root of 4, plus 2 minus 1 is 1, and 1 squared is 1. And 4 plus 1 is 5. So this is the square root of 5 units, and that is your distance, the square root of 5 units. Leave your answer in simplified radical form for these problems unless you are requested to work with decimals. Example number 2 says, use the distance between the point to find x. So what you're given here is you're given an actual distance. In this case, you're given that the distance is 4 square roots of 2. I'm also giving you one of the points. And what we need to do is we need to find what the value of x is. We have x negative 5. So I'm going to use the distance formula. And I'm just going to substitute all of my information into that formula. So I'm going to write 4 times the square root of 2. That's my distance. That's going to be equal to the square root of, and I'm going to do x2, which is x, minus x1, which is 2, squared, plus I have negative 5 minus negative 1. And then we're going to square that. So in order for me to solve this equation, I'm going to clean up this problem underneath the root a little bit more. So I have 4 square roots of 2 is equal to, since x minus 2 squared is just, I can FOIL it out if I choose, but I think it's actually a little bit easier just to leave it as an x minus 2 squared for right now, plus negative negative makes a plus sign, and negative 5 plus 1 is negative 4. Negative 4 squared is 16. Now, since the main operation under the root is addition and not multiplication, I can't do anything at this point. So my goal is to get x alone, which means I need to get rid of the root. And the best way to get rid of a root is to square both sides. So I'm going to put parentheses around both entire sides, and I'm going to square both sides. What's going to happen here is I'm going to square each piece. 4 squared is 16, and the square eliminates the square root, leaving me with 2. 16 times 2, that is 32. Next, the square eliminates the square root, leaving me with x minus 2 squared plus 16. At this step, I'm going to get that x minus 2 squared alone, so I'm going to subtract 16 on both sides, and I end up with 16 is equal to x minus 2 squared. So in order for me to get rid of the square, I'm going to take the square root of both sides. You could, if you wanted to, FOIL that out and start working with properties that we've worked with in the past where we've factored it and things of that nature, but it ends up being a little bit more complicated. I think it's a little bit easier just to take the square root of both sides. But you have to be careful. Whenever you take the square root of both sides, because it's an even root, we're going to end up with 2 answers. The square root of 16 is plus or minus 4. The square eliminates the square root, and we have x minus 2. So what that means is that we're going to add 2 to both sides, and when we do that, we end up with 2 plus or minus 4 is equal to x. So that means that we will have 2 solutions, 2 ordered pairs that are equidistant away from equidistant from 2, negative 1. So my first answer is going to be 2 plus 4, which is 6, so x could equal 6, or 2 minus 4, which is negative 2. So what that means is that our ordered pairs, if I were to plug that value of x into my ordered pair, we would have 6, negative 5, or our ordered pair would be negative 2, negative 5. And both of those ordered pairs are 4 square roots of 2 units away from 2, negative 1. That's what this means. So just be prepared that for these types of problems, you may end up with more than one answer, more than one solution. Let's go ahead and look at example number 3. In example number 3, we want to classify, which means give it a name, classify the triangle as scalene, isosceles, or equilateral, and we want to show work. And in order for us to classify, we need to identify the lengths of all of the sides of the triangle and see if any of them are the same. So the first thing that we want to do is we need to identify what our ordered pairs are for A, B, and C. The ordered pair for A is we're going to go over 1 and up 5, so that's 1, 5. The ordered pair for B, we're going to go over 5 and up 3, so that's going to be 5, 3. And the ordered pair for C is we're going over 2 and up 1, so that's going to be 2, 1. And I'm going to work with these ordered pairs in order for me to identify my side lengths. Now my side lengths, that's going to be AB, BC, and AC. So these are the side lengths that I'm going to be working with. AB, BC, and AC. So I'm going to identify the distance between the points using the distance formula. So I have x2, which is 5, minus x1, which is 1, squared, plus y2, which is 3, minus y1, which is 5, squared. So 5 minus 1 is 4. 4 squared is 16. Plus 3 minus 5 is -2. -2 squared is 4. I end up with the square root of 20, and the expectation is that you're going to simplify all of your square roots. Now 20 has a perfect square factor of 4, so that's going to be the square root of 4 times 5, and my simplified answer is 2 square roots of 5 units. Next, I'm going to identify the length of BC by using the distance formula. And so I'm going to go 2 minus 5 squared plus 1 minus 3 squared. That is equal to 2 minus 5 is -3. -3 squared is 9. Plus 1 minus 3 is -2. -2 squared is 4. And 9 plus 4 is 13. So that's simply the square root of 13 units. Next, I have AC. So I'm going to take the square root of 2 minus 1 squared plus 1 minus 5 squared. That is equal to the square root of 2 minus 1, which is 1, 1 squared, which is 1, plus 1 minus 5 is -4. -4 squared is 16. And 1 plus 16 is 17. So we have the square root of 17 units. 2 square roots of 5, square root of 13, and square root of 17 are not all the same number, which means that all of these side lengths are different, indicating that we have ourselves a scalene triangle. And that is our answer. Let's go ahead and move on to the next page. For this next page, we're going to be writing equations of line segments that are going to represent perpendicular bisectors or tangents of a circle, tangent lines to a circle. So given a line segment, what would you need in order to find an equation for the perpendicular bisector of that segment? So there's a few things that we need to know. First of all, there's going to be a line segment that's going to be a perpendicular bisector line. There's going to be a line that's going to intersect this line segment at a specific point. So if we want to find an equation of a line, that means that we're looking for our equation to be in the form of y equals mx plus b. And a perpendicular bisector means that it's going to have opposite reciprocal slope. That's what we know about perpendicular lines. They will have opposite reciprocal slope. And bisector means that it cuts a segment in half, which means that it intersects at the midpoint. So this is now where we get to work with our midpoint formula and our slope formulas. So just to make sure that we're all on the same page, our slope formula, remember, is y2 minus y1 divided by x2 minus x1, just so that we're all on the same page. So what we want to do is we are going to be given a line segment, which means it's going to have two ordered pairs that's going to be attached to it. And we're going to need to identify what that slope is so that we can identify the perpendicular slope for that line segment. And then we're going to need to identify the midpoint of that line segment so that we know the location in which the perpendicular bisector is going to cross it. So there's two things that we need to know. First of all, we need to know the slope of the line segment. So we're going to identify the slope of that line segment. So we're going to use this to identify the perpendicular slope, which is going to represent the slope of the perpendicular bisector. And once again, remember that perpendicular slope is going to be opposite reciprocal slope. The second thing that we're going to do is we're going to identify the midpoint of the line segment. And the reason why we do that is because that represents the location where the perpendicular bisector intersects the segment. All right, so if we wanted to write an equation of a perpendicular bisector, what we need to do first is we need to find the midpoint. We need to find the midpoint of our line segment. Then we're going to calculate the slope. We'll calculate the slope of our line segment. Then, once we know the slope of our line segment, we then need to identify the slope of our perpendicular bisector. And that slope is going to be perpendicular. We're going to find the slope perpendicular to the slope of the line segment, which once again, that is going to be the opposite reciprocal slope. Then we're going to use y minus y1 equals m times x minus x1, which is known as the point slope formula. In order for us to identify our equation of our line. So we're going to use the slope formula, or the point slope formula, which means that x1, y1 will come from our midpoint, and we'll use our slope, which is going to be our perpendicular slope. So we're going to substitute our x and y values from our midpoint. We're going to use our midpoint, as well as the slope value that we got for our perpendicular slope. And then from there, we're going to solve for y. And once we've solved for y, we should have our equation in the form of y equals mx plus b. Let's go ahead and look at example number 4 and actually apply these steps. So if we wanted to write an equation of the perpendicular bisector of a line segment joining points A and B, the first thing that we need to do is we need to identify our midpoint. So our midpoint, that's going to be the average of our x values. We have -2 plus 4 cut in half, and 1 plus -7 cut in half. -2 plus 4, that is equal to 2, and half of 2 is 1. So we have ourselves 1, and 1 plus -7 is -6, and half of -6 is -3. So there's our midpoint. The second thing that we need to do is we need to identify the slope between our 2 points. This is the slope of the line segment. So I'm going to write m is equal to, so that's little m is equal to y2 so that's going to be -7 minus 1 divided by 4 minus -2. So that's y2 minus y1 divided by x2 minus x1. So we have -7 minus 1, which is -8. And negative makes a plus, so we have 4 plus 2, which is 6. And that simplifies to -4/3. Then from here, step number 3 is we need to identify our perpendicular slope. Our perpendicular slope is the opposite reciprocal. So that means that our reciprocal is going to be 3/4 and the opposite sign is positive. We're going to use our perpendicular slope and we're going to use our midpoint in the point slope formula. So that is step number 4. We're going to write our equation. So I'm going to go y minus y1. y1 is -3 is equal to m. My slope is 3/4 times x minus x1, which is 1. Now from here I need to solve for y. So I'm going to make that negative a plus. And I'm going to distribute that 3/4 to each term. So I have y plus 3 is equal to 3/4 x minus 1. I'm sorry, minus 3/4, excuse me. I'm going to subtract 3 on both sides. And when I do that, I now have y is equal to 3/4 x, and I need to come up with a common denominator. So my common denominator is 4. So if I were to multiply 3 times 4, that's really going to be 12. So this is minus 12/4. And so if I were to subtract 3 minus 12, that's, or -3 minus 12, that's going to be -15/4. And there is my answer. All right, next, let's go ahead and look at example number 5. We're doing the exact same thing in example number 5. We want to identify the equation of the perpendicular bisector line joining C and D. So the first thing I'm going to do is identify my midpoint, and that's going to be the average of my x values, which is -5 plus 5 cut in half. And we have 0 plus 4 cut in half. Negative 5 plus 5 is 0, and anything over 0 is going to be 0. And 0 plus 4 is 4, and half of 4 is 2, so 0, 2 is my midpoint. The next thing I need to do, I need to identify what my slope is. So that's going to be m equals y2, which y2 is 4, minus y1, which is 0, divided by x2, which is 5, minus x1, which is negative 5. Please be careful with your signs. We end up with 4 over 10, because negative, negative makes a plus, and 4/10 simplifies to 2/5. Step number 3 is we need to identify our perpendicular slope. So that's going to be the reciprocal, 5/2, and it's going to be negative, opposite reciprocal slope. We're going to use our midpoint and our slope in order for us to write our equation. So that's step number 4, our equation. So I'm going to go y minus y1, which is 2, is equal to my slope, which is negative 5/2, times x minus x1, which is 0. Anything minus 0 is just itself. So I have y minus 2 is equal to negative 5/2 x. I'm going to add 2 to both sides, and I find that my equation is y equals negative 5/2 x plus 2. And that is my answer. So now what we're going to do is we're going to write equations of tangent lines. And remember that tangent lines, or a tangent to a circle, is always perpendicular to the radius of that circle at a point that we call the point of tangency. So in order for us to identify the equation of a tangent line to a circle, we need to identify a few things. First of all, we're going to be working with the exact same steps as what we did up here. The only difference is that our line segment is going to be our radius. So just like we needed to identify the slope of our line segment as one of our first things that we needed to identify, this time around we're going to identify the slope of the radius. And why? Because our radius is our line segment. And so what we're going to use is we're going to use the 2 points on our our radius, on our line segment. So we're going to use the center and the point of tangency. Why? Because a radius always goes through the center, and we want to find the perpendicular bisector, and the perpendicular bisector will always go through, or our line of tangency, which is the perpendicular bisector, will always go through that point of tangency. So those are going to be the 2 points that we're going to be working with in order to find the slope of our radius. The next thing that we need to do is we need to use that point of tangency to write our equation. So we're going to use the point of tangency and the slope of the radius to write an equation. So if we wanted to figure out what is the equation of a line that is tangent to a circle, our circle in this case is x squared plus y squared is equal to 61. Going back to what we remember about circles, if you don't see any parentheses around the x and the y, that indicates that our center is going to be located at 0, 0. So we have ourselves, what is the equation of a line tangent to a circle at the ordered pair 5, negative 6? 5, negative 6, this represents our point of tangency. So the first thing that we need to do is we need to identify the slope between the center and the point of tangency. There does exist a shortcut, but I'll let you figure that out on your own. So I'm going to go negative 6 minus 0 divided by 5 minus 0. And that's going to be identifying the slope between my center and my point of tangency. I end up with negative 6/5. So that's the slope of my radius. Now I need to identify the perpendicular slope of my radius. So that's going to be where we take the opposite reciprocal. So the opposite reciprocal of our slope is going to be equal to 5/6. So we're going to use that perpendicular slope, and we're going to use our point of tangency to write our equation. Our equation is going to be y minus y1, which is -6, is equal to our perpendicular slope, which is 5/6, times x minus 5. I'm going to distribute that 5/6 to each term and change my negative to a positive, and I end up with y plus 6 is equal to 5/6x minus 25/6. I'm going to subtract 6 on both sides, and now I have y is equal to 5/6x, and now we need to work with this -6 in order to combine my like terms. If I need a common denominator of 6, I'm simply going to multiply this 6 by the denominator to make it 36. So this is going to be -36 over 6. And -25 plus a -36, that's equal to a -61. So that's -61/6. And there is our equation. If you would like to pause the video and try example number 7 on your own, I strongly recommend that you do so, just to make sure that you feel comfortable with this concept. Otherwise, go ahead and sit tight and see what I do. So the next thing I'm going to do is I'm going to write an equation of a line tangent to a circle, given that my circle is at x squared plus y squared equals 37, which simply means that the center is going to be located at 0, 0. And we have our point of tangency being 6, 1. The first thing we need to do is we need to identify our slope. So I'm going to go 1 minus 0 divided by 6 minus 0, which is going to be 1/6. The second thing I'm going to do is identify my perpendicular slope, which is going to be 6 over 1, and a negative. That's going to be -6. And then I'm going to use that perpendicular slope and the point of tangency in order for me to write my equation. So that's going to be y minus y1, which is 1, is equal to my slope, which is -6, times x minus x1, which is 6. So I have y minus 1 is equal to -6x plus 36. So I'm just distributing that 6 to each term, or to each term. So I'm going to add 1 to both sides in order to get y alone, and I end up with y is equal to -6x plus 37. And that is my answer, as well as the end of this lesson. Hopefully this lesson was not that bad for you, but if you find that you do have questions, please feel free to email me. Otherwise, I hope you have a wonderful day.